right, so when we talk about prescribed fire, the reason why we call it prescribed fire is because we're writing a prescription. And so that means that we're able to choose not only what fuel we're burning, but also the weather conditions. So we basically get to dictate how we burn it. And so, in order to understand how we're going to burn it safely, you got to understand a little bit about fire behavior, of how fire acts on the landscape. So this is kind of it. We're going to go through some of the very basic stuff. There's a bunch more behind this, but we're going to keep it real simple. So fire behavior basically is how our fire is interacting and responding to the environment. There's all these different factors that go into it. Wind speed, direction, humidity, mixing height, what our fuels are, slope aspect, rate of spread, all these different things are basically in the environment affect our fire behavior. So it's also a conditional measure. So in some instances, we want certain behavior, but then we also want to discourage certain fire behavior that's going to be against safety. But the weird part is sometimes we encourage and discourage fire behavior on the same exact fire. So this is probably one of the hardest things for people new to fire to look at is fire behavior, because it's something that really can't be learned through PowerPoint. It's something that has to be learned on the fire. So think about if you're on a prescribed fire this year, look at these different factors on the ground and like how they react to your fuels that you're burning with. So some very basic stuff here. We basically need three elements for the fire to start and continue, right? Oxygen, heat, fuel. Take away one of these things. If we remove oxygen, it's going to inhibit combustion. So think about, we're going to use a flapper, we're going to put it on a fire. It's basically going to starve it of oxygen and it's going to put it out temporarily. Same thing if you remove heat, right? If it's negative 40 degrees out, it's going to be really hard to get a fire started than if it was 90 degrees outside. It's going to be much easier. And obviously, if you remove fuel, it's going to be hard for a fire to start or keep going. Now, there's three environmental factors that we're going to look at. We're going to look at topography, fuels, and weather, and kind of some of the things that interact with them. So here's our fire behavior firing triangle. The most variable and unpredictable of all three of these is obviously going to be weather, right? Weather is always constantly changing, which means our fire behavior on the fire line is going to be constantly changing. It's typically never static. Topography obviously is going to be our most stable factor, right? It's not going to change. We can manipulate topography to some extent, right? If you've got a dozer, we can manipulate the topography a little bit, putting in different like access points and stuff like that. But in general, topography is not going to change. Now, there's a couple different elements of topography that we want to look at, slope and aspect, just very broad generalizations. Slope, obviously, fire burns faster uphill. Their material can potentially roll down the hill of steep slopes. And then an aspect can also affect your fire behavior from like the heating of the sun, moisture accumulation, and even type of vegetation. So in general, in most of Nebraska, I would say we have gentle slopes. There are some areas where steep slopes are, but there are steep slopes. Flames basically will preheat fuels as they go up. So that radiant heat will cause them to take moisture out of that fuel before the fire gets there. So when that fire gets there, it goes faster. And then obviously it's going to spread much quicker going up a steep slope. So your intensity is going to be greater. So obviously steep slopes are a bad place to put fire breaks, like on top of a hill on a steep slope. It's generally a bad area to actually put a fire break because you're going to have embers and stuff jump over. Now on gentle slopes, which majority of Nebraska is, fire behavior is more dictated by the fuels and the weather than the actual slope. And we'll show a video later on where you'll see a backing fire going up a hill pretty slowly. So if that was a really steep slope, that fire would be more influenced by the slope than it would be by the wind. When we talk about aspect, just recently here in Nebraska, we started getting some, the low angle of the sun, getting warm weather. But if you go look at any kind of ditch or anything like that, the south and southwest aspects, they've got that really high sun exposure. So they're exposed to more higher temperatures, lower humidity, lower fuel moisture. So they're drying out faster. So right now I'm looking out at my woodlands, and I could probably go out there right now and burn my south and southwest aspects currently, but I still got snow in my north aspects. So that can affect your fire behavior. Now, in general, throughout Nebraska, aspect is not going to have as great of effect as would maybe if you're burning in the mountains or something like that. The one-time aspect would be more of a factor would be like early morning. So let's say you go out early morning and there's a little dew on the ground and that sun starts to burn off that south and southwest aspect. Well, it's going to burn differently there than it would maybe on the north side until that sun gets higher in the sky in the afternoon. So it's going to have kind of minor effects on your your fire behavior. But obviously, fuels are the main source of energy of a fire, and basically can include anything that burns. So here in Nebraska and throughout the Great Plains, the majority of our fuels are going to be grasses, and we break those down into different grasses like cool season grass versus warm season grass. If you're not familiar with those terms, cool season grass is basically grass that grows kind of during the cooler part of the year, so early spring and then late fall. And then the warm season grass is the stuff that really grows with that really high temperature and sun. So big blue stem, little blue stem, such as that. Now we also have timber that we burn throughout, and there's a couple different. We have evergreen timber, which consists of like eastern red cedar trees. We're not trying to like maintain a eastern red cedar savanna. So when we're burning cedar trees, we're trying to canopy fire them. Now the opposite is very true with ponderosa pine. Ponderosa pine, we're trying to burn the understory and not up in the canopy. So two different things there. But then we also have deciduous, where we're typically burning the understory of those, and most of that is oak. We typically don't burn a ton of cottonwood along the river, but we do some. So there are several factors, these fuel characteristics that we look at that help us predict the fire behavior on the ground. So we'll talk about some of these things. I don't want to get too far into the weeds on some of this stuff, but fuel loading, chemical content, moisture content, continuity are really important factors. So the first one is obviously fuel moisture content. So in grass, there's a high surface area to volume ratio. So essentially, grass can take on moisture really fast, and it can also expel moisture really fast. So imagine like in the morning, there's dew on the ground, and then as soon as that sun pops out, it starts to dry out that moisture. So it sucks that moisture out. And so it could change within an hour. So we could be burning, it could be wet at 9 o'clock in the morning, and by 10:30, it's dry enough to burn. Now, timber, on the other hand, let's say, we're talking about cedar trees. They don't take moisture very well. So they don't take, if they're full of water, right, in May and June, hot sunny day is not going to cause those things to dry out very fast and burn better compared to that. When we're talking about timber in like a deciduous oak woodland, that also has slower drying for that reason too, because we got increased shading on the land too. and also the compactness of the leaves on the ground have to dry out underneath of them. So they obviously don't burn very well wet at all. Fuel continuity is probably one of the biggest things that we look at. Obviously, grass is typically more continuous, right? There's variable changes, small changes throughout the continuity, but in general, you're going to see large continuity throughout there. So that's like our biggest fuel source and what we're typically burning. Now with timber, when we're talking about cedar trees tend to be more patchy, so they tend to be kind of clustered, or they may be kind of like single isolated trees on the landscape. So that continuity is a lot harder to get going and get those trees going than it would be the grass. So here's a good comparison. Here on the left side, you can see this grass is very continuous, easy to burn. We got different types of grass. Looks like maybe some brome or even just grazed down fuel. So even there, we get different continuity, but it's still continuous. Now on the right side here, you have discontinuous fields with cedar trees, right? These cedar trees aren't touching. And then also this pasture is grazed down. So it's going to be very hard for a very continuous fire to happen on this. So you'd either want to defer grazing or potentially go in and cut these trees before you burn. Or if you did what I would recommend is I'd burn first and then go cut the trees that you didn't get. When we talk about rate of consumption, obviously grass burns really fast and more complete, right? So typically when we burn a grassland, we see, 90 to 100% consumption of that grass. In timber, like cedar trees, obviously cedar trees don't burn very slow. If you've ever seen a cedar tree go up, they go up pretty explosively, but they don't consume the whole thing, right? You still have the skeleton that remains. You burn off all the needles, but the skeleton remains. In an oak woodland, you're burning off leaf litter. So you have very discontinuous fuels, and then it also doesn't consume very fast. It's really slow moving fire. I've seen deer jump over the top of them. And then also, obviously, if you get into a woodland situation where you're burning logs, you have the potential to reburn hours or days after a burn. So you need to make sure to watch that. So here's an example. On the left side, you're going to get 90 to 100% consumption. On the right side, on the cedar tree, it's going to consume really fast, but typically you're not going to be burning these the stems or the logs out there, and they're going to be standing for quite a while. And we typically just leave them. Fuel load is really big, right? So there's a huge difference between burning a hay brome pasture versus burning a CRP that hasn't been burned or hayed in 5 years, right? You're talking about a couple tons per acre versus like 6 or 7 tons per acre of fuel. And that makes a huge difference in your fire behavior on the ground. CRPs are when we burn CRP, they can be very misleading because they have a lot of fuel buildup in them. And so they typically can be more dangerous to burn than rangeland where they have a lower fuel load. Then when you add cedar trees to the mix, that kind of changes the whole thing. So if you're burning in areas where you got cedar trees on the left, those cedar trees are still pretty small, not going to change your fuel load that dramatically. But if you look on the right side, you can see how big those cedar trees are. And that's going to add a lot of fuel load and change that fire behavior very dramatically. So chemical content, pick your area. Here in Nebraska, our two biggest ones, switchgrass. Switchgrass because it's got volatile oil in it. So if you burn a patch of switchgrass, it behaves completely different than if you're burning little blue stem or big blue stem. It's got this oil in it that just makes it really snappy. The same thing with cedar trees. If you get up into the canopy with cedar tree, these volatile oils in these cedars basically just make them explode, which is really cool, but also can change our fire behavior and make it more dangerous. So we have to mitigate that. So obviously, some grasses are going to burn differently, and one could be litter accumulation. So the compactness, maybe we get a really heavy snow and it pushes all the grass down. That could change our fire behavior just by the weight of that and the compactness of it. Also, if you burned, if you haven't burned in 15 years and hasn't been grazed, you got a lot of litter that could change fire behavior. Also, the condition. If you look at this past year was burned, but it was late April or mid to late April and it's starting to green up really good. So it didn't burn very well. So just that condition. And that goes back to kind of what our fuel moisture did. All right. So talk about topography and fuels. Now we're going to kind of move into weather. And again, remember, weather is the most variable portion and probably the most critical thing that we look at and why we call it prescribed. So in order to make it a prescription, we have to come up with, okay, what are the parameters that we use to burn that are going to be safe and accomplish our objective? So there are several variables. These are the main ones that we're going to talk about that are the most common: temperature, relative humidity, wind, precipitation, sky cover, and stability. Like I said, there's more factors in weather that we look at. These are kind of the main ones that have an effect, biggest effect. Now, I'd say the biggest one is relative humidity. So, and this is the amount of moisture in the air. As the air becomes, more dry, that moisture is pulled from those fuels. So, obviously, if you think about, grasses in the morning, you have high humidity in the morning. You're going to have dew on the grass. And throughout the day, as that sun comes up and that relative humidity starts to drop, it's actually pulling moisture from that plant. Grasses is just really more dramatic. Maybe in cedar trees, it has less dramatic effect on it. So basically, that low humidity is going to cause an increase in fire behavior. So that's why, if we get down to 20% humidity or below, like it is today in western Nebraska, it's going to cause very explosive fire behavior because it's basically zero moisture in the fuel. It's not that the humidity causes the fire; it's the fuels, the humidity taking the moisture from the fuels because they're trying to reach an equilibrium. So this obviously increases our chance of spot fires. So if you're burning below 25% humidity, just be very cautious on burning. Increase your chances. So there's an inverse relationship with temperature and humidity. So if you look at the graph here on the right, right here, at 87 degrees, if you follow it all the way down to the humidity, this green line, that's 18% humidity. So at the warmest part of the day is typically going to be the driest part of the day, right? So we use that to our advantage because we can predict that, because the warmest part of the day is usually always going to be late afternoon when the sun is the highest, right? So we can use that to gauge what our conditions are going to be. Now, in this case, if you wanted to burn, this would be a great burn day if you were wrapped up by, got the fire done by 1 o'clock or 2 o'clock in the afternoon when the humidity was still above 20%. So, but then once that afternoon hit, it's going to be a pretty volatile day. So obviously wind are going to be our most difficult factor to predict. It's going to be the most variable, and it can also be influenced by terrain. So it's really hard to predict wind, but you kind of have to use it to kind of mitigate on the ground. And we'll talk a little bit about that. So one of the biggest misconceptions I think we see with new burners is that burning with less wind is safer than burning with more wind. or burning with no wind. So a lot of times we see people go out and, in the evening after the wind dies down, and they think that that's the best time to go start a fire. And that may be true in other parts of the country or world. They do that. But in Nebraska, I always want to have at least a 5-mile-an-hour wind because it determines direction. So think about no wind situation. So you go out and light a fire, and we've seen this happen 100 different times. What happens is you go out and light that fire, and the fire creates its own little micro environment. So at one time, the fire can be racing right directly at you, and it'll stop dead in your tracks and then take off the other direction. It'll kind of just continually do this randomly, and that's not good, right? We want to know where our fire is going to go, and so having that minimum of 5 miles an hour gives us a good indication of uh, where that fire is going to go. And obviously, wind increases the amount of oxygen supply that gets into our fire. So if you have ever started a fire in your fireplace or a campfire and you can't get it going and you're having trouble getting the paper to light, what do? You blow on it. What do you do when you're blowing on it? Well, you're increasing the oxygen supply into that fire. So that fire behavior is going to intensify. It also influences that speed of the fire, right? So think about, a moderate amount of wind versus a strong wind. It's going to move a lot faster. But on the other end too, we can actually use really strong wind to actually put fire out. So we use backpack blowers that blow like 200 miles an hour, and they actually will put out wind, snuff out the wind. And then, of course, the big one too is increasing fuel drying. So that fuel drying, that wind is basically sucking out moisture. So imagine like you're standing in the wind, your lips get chapped and stuff like that. The same thing happens with fuels. Now, wind also influences our environment through smoke and flames and stuff. So, wind can carry sparks and firebrands across our fire line, right? They can also bend the flames that preheats the fuels, but it can also disperse smoke in areas of our choosing, which is a good thing. So, if you look at this picture on the right, you can see that, burning with not much wind will help get that smoke kind of more straight up and down. And then as you increase that force of that wind, what's going to happen is it's going to lay that smoke down. So if you're trying to not get smoke in the town or something like that, you obviously don't want to burn with, a 20 mile an hour, 25 mile an hour wind because it's going to make that smoke hug the ground further. But obviously you don't want to burn no wind like we just talked about. And a big one is carrying that sparks over our fire line is a big factor as well. So precipitation can also affect, like I said, precipitation can, if it rained like a little bit in the morning in grassy fuels, by the afternoon, you potentially could burn pretty well. So single events don't usually impact moisture levels in heavy fuels like trees, right? It takes longer time to soak that up. Single precipitation events lead to emergence of green vegetation. So like right now, if we get a good rain and it really warms up, we're going to start seeing the emergence of cool season grasses, which is going to affect our fire behavior. The other big thing that affects fire behavior is actually our ground moisture. So if it's really dry on the ground, between the ground and the herbaceous fields or the fields, it creates kind of a microenvironment. So if you've got good moisture in the ground, it actually will help suppress some of the fire behavior versus if it's really dry, it would actually increase our fire behavior. Temperatures, obviously, hot temperatures are going to accelerate evaporation. So, obviously, taking precipitation or moisture out of a grassy fuel at 40 degrees is going to take longer than if it was at 90 degrees. So basically it reduces the amount of energy needed to ignite our fuels. So just think about it as higher temperatures basically mean increased fire behavior. Sky cover, cloud cover can affect fire behavior basically by increased shading on our fuels, which give it less drying of fuels. So this can have minimal impacts on our grasslands that we're burning typically, but early in the season, like right now, if we're burning oak woodlands, uh, it's really interesting when you burn an oak woodland and one cloud starts shading out that sun, our fire just dies on us. And then when it comes back up, you can see it kind of increase a little bit. So it's actually pretty cool. So, but if it was like, 100% shaded, 100% cloud cover, then that could affect your fire behavior as well. One of the really big things that affect fire behavior is what we call atmospheric stability. Atmospheric stability is basically, it's about the drying of the lower atmosphere. So a stable atmosphere will basically suppress upward motion. It'll limit that indraft into a fire. So think about when you're doing your fire in your fireplace and you open up your flue, you get that indraft coming to help feed that fire. A stable atmosphere helps resist that. So these are days that are going to be poor visibility, have hazy days, stratus clouds, stuff like that. Now, on the other hand, we have an unstable atmosphere, which encourages that upward motion, those updrafts, right? We see this when we get those big, nice spring thunderstorms. We get these big updrafts and they cause these huge thunderstorms. So you can see this where they have gusty winds. We get dust devils on the landscape, fire whirls. All these different things create an unstable atmosphere. Now, there's a way to determine this. It's called the Haynes Index, right? And it's basically from 2 to 6, 2 being very stable, 6 being very unstable. Now, in Nebraska, we're typically burning at either the 4 or 5 level. That's typically our best burn days is when we're burning. And I'll show you where to find all this information on the website or the Weather Service later on. But 6 is very high. 6, you're going to see problems with dust devils, fire whirls that could go across your fire line. Now, we do burn on days of 6, but the thing is, when we do burn on those days, we just got to make sure that we are mitigating that with our other parameters and stuff. So this is a dust devil. And these can actually carry very hot ash and then cross our fire break and start fires and ditches and fuels across the fire break. So if you see one of those, make sure you jump on it and go chase it down to see if it starts any spot fires. We've had several of them the last couple of years that have done that. Chase those down. Here's the fire whirls. You can kind of see these are kind of more pretty small, but they can get high up into the air and detach from the flame front. So there are days that we do not want to burn, and the Weather Service does a really good job of like issuing what we call red flag warnings. This is when they're going to have strong shifting winds, low relative humidity, high temperature, and unstable atmosphere. So we don't want to burn during these days, but also if you have one of these after you burn, like so let's say the day after you burn, you always want to make sure that you go check your burn unit the day after. So we don't use this rule of thumb much anymore, except for when we talk about kind of dormant grass fuels. So when we talk about dormant grass fuels and burning, we try to stick to this and say we don't want to burn over 80 degrees. And we don't want to burn over 80 degrees because typically in the dormant springtime, what happens is that if it gets above 80 degrees, that means our humidity is going to get even lower than it is, right? So our humidity, if we get below 20%, we don't want to burn. So we want to be above that. And then we don't want to burn over 20 miles an hour. Now, if you went out and burned on this day, if it was 80 degrees outside, 20% humidity and 20 mile an hour wind, it would be a very challenging day to burn. So do not do that. So it's about finding balance of trying to figure out good days to burn. Now, the other day when we burned, it was like a perfect day. It was like 68 degrees, 30% humidity, and 10-mile-an-hour wind. Like if I could pick a day to burn grasslands here in Nebraska as maintenance burns, that would be it. But we always don't get to choose. Now, have we burned on days like this? Yes, probably not up to 20 miles an hour. If I was going to burn with 80 degrees and 20% humidity, I'd want my wind speeds to be low or lower than 20 mile an hour. So we see characteristics of extreme fire behavior, crowning, spotting, large fire whirls, dust devils, aggressive rate of spread. And most of the time, that's all due to either, to excessive fuels, low fuel moistures, or low relative humidity, which are both combined or, together really. Same thing with high temperature and an unstable atmosphere. So if you're just starting out burning, you can develop a conservative burn plan, like I was talking about earlier. You want to make sure you follow that burn plan, monitor your weather throughout the fire. The one thing you want to look at too is, let's say you're forecasted to be 80 degrees during the day. Well, what happens if you pull out your Kestrel weather meter, which we'll talk about later, and it says it's 85 degrees? Automatically, you already know that your humidity is even lower than it was forecasted. So if you're already forecasted at 20% humidity and you're at 85 degrees weather, you already know your humidity is probably in 16 or 17. Maintain communication on the fire is absolutely imperative. And then also call off your burn if necessary. If you get to the site and need to call off the burn, do so. Now, again, so fire behavior is all about, right? We're writing a prescription. And so we're predicting our fire behavior predictors. So the art of this is to take these low intensity factors and these high intensity factors and weave them together to come up with a prescription that's going to meet your objectives, right? So if you can get away with a high relative humidity, and high winds, do that, or low winds and high relative humidity. All these different things. So it's kind of like it's one of these things you learn on the fire over the years is how to take these different factors and weave them together to make sure that you're staying safe and within prescription.